We've handled storage and we've handled the installation. So now what do we want to do with this new server? There are three things that I want to focus on that pretty much any internal server is going to use. Intranet or internet servicing, which is to say that you're servicing web pages, probably back to some sort of database backend. Storage services, specifically Windows file sharing, and network services, things like DNS and DHCP. I'm going to approach each of them in turn, and first we're going to start with intranet pages using a web server and MySQL as a backend. I'm considering an intranet backend any type of web service that you run that's more or less pure internal and is designed just for the use of your local house or your company. We have to address three things here. First, on the technology stack, we have to have some sort of web server. The Apache web server is pretty much the de facto standard in the Linux world. Most intranet applications also need some sort of database backend. For that, we're going to be using MySQL. And almost all of the intranet apps that you use are written in something other than pure HTML. So there may be PHP, Ruby, Perl, or anything like that. I'm going to focus on PHP because most of the common intranet apps that you're going to run into are going to be using PHP. First up, we're going to need a web server. Pretty much everybody out there is going to recommend that you use Apache to start off with. I'm no different. So we're going to go ahead and search through the Ubuntu repositories for a specific version of Apache called the pre-fork runner. When I do the apt search, you can see that it shows up a number of things. So libapache modules and some random just libraries that go with Apache, lots of which are not what we're looking for at all. So I happen to notice that as we're scrolling through, some of the things look more web servery than others. Specifically, there was a series of packages that listed HTTP server in them. That's probably what we're looking for, so I want to refine my search a little bit better. And I'm going to apt-cast search for Apache HTTP. It should show us a small list of things that are more directly related. Specifically, this list here shows different versions of the Apache worker model. Apache npm prefork is a multi-processed model that preforks a number of child processes from Apache. That's what we want to use simply for the fact that we're going to be using PHP also. PHP doesn't necessarily work with the other threading models. Once the installation is done, the normal Apache process should have automatically started up. Verifying that it's running here, because if it's not, there's a lot of debugging stuff that's not going to make sense, so this is easier to check now than it is to realize later that it never started up in the first place. With the server started, we can move immediately into configuring it. Almost all the configuration stuff that's in for Apache from the Ubuntu package is going to be pretty much the default safe setting. It's going to start, it's going to run, and it's going to serve out pages from var ww immediately without any type of additional configuration. However, in etc Apache 2, there's a series of subdirectories and configuration files that we should probably look through really quickly. The first one is in etc Apache 2 sites enabled. There are a series of symlinks in this directory that point to files that define configurations. They're roughly HTML or XML-like. As you go through the file, you can check the different configuration directives, which I've highlighted. I won't go over each individual one because it's easier to kind of pause here and read through, look at what the screen looks like. But basically, each individual file defines a virtual host or a host name that Apache answers for. I'm highlighting here the parts that I think are the most important. Logging, the base directory, the host name for what you're serving out for. All of these are things that you're going to want to configure or leave as the default for the most part, but be aware of where the configuration settings go to. The first thing to be aware of is a setting in the top of the file called the document root, which by default is pointed at var www. What we want to do is check out what's in var www. Since that's the package installation default, the only thing that's in there is an HTML file that lets you test whether or not Apache is working. So when you load up Apache for the first time off of this box, the contents of var www will be parsed and thrown to your web browser, just like any other web server on the internet. Even though we've verified that Apache is running, we do want to make sure that it's actually serving out pages. So I have to get my IP address. Once I've gotten that, I can point it into my browser on whatever my operating system of choice is, go directly to that IP, and it should serve out the default HTML file. Flipping into a Chrome window, I can go ahead and put in the IP address. Once it loads, it should show us the default HTML file that we had just looked at before. It does. That means Apache is working okay and we can move on. In the entirely likely event that you don't trust your own web server, and you probably shouldn't on your first installation, go ahead and change the file so that we can reload the initial website. Make sure that it's actually showing the modifications, and then verifying that one, you have the right IP address, two, that Apache's pulling from the correct location, and three, that it's not caching somewhere in the middle like a transparent proxy server or something even stranger. Changes that you make to a normal HTML file like this should be instantaneous. The browser could cache them, so you may have to do a shift refresh instead of just a regular refresh. Now, with my paranoia satisfied, I can go ahead and move on to configuring something else. Apache by itself isn't really complicated to set up, and it serves out web pages like nobody's business. But what we probably want for our intranet service is to run some third-party application. I'm going to assume, again, that it's written in PHP, so that means we need to install PHP first. Apache uses modules to extend functionality. In this case, we want to install the libapache2 mod PHP 5 module, which will enable PHP 5 inside of Apache without having to deal with getting a CGI version of Apache up that causes PHP to run all the time. As part of the package installation, apt-get is going to go ahead and enable the Apache 2 configuration for PHP. The way it does that is by going into the mods enabled subdirectory in etc Apache 2 and doing a soft link into the PHP configuration files for mods available. You can also do this by hand at any time and simply restart Apache afterwards. As you can see, the two files there, php5conf and php5load, are symlinks to mods available. I'm going to restart Apache just for good measure, although generally you would have to take a downtime to do this, so you wouldn't want to do it on a production server for no reason. To make sure things are configured properly, I want to test the PHP rendering engine the same way that I tested the HTML rendering engine of Apache earlier. So I'm going to create a simple, basic, default kind of PHP file. If you don't know PHP, that's fine. You can steal this directly and it will work on any PHP server. All it's doing is dumping a function that shows all of the relevant information about PHP and a lot of information about Apache and the server in general. This is good enough to test a basic installation, so we have to hop back to the web browser to check it out. Apache has a file search order. When you name something index, it's going to search through a series of index files in order, the first being index.html. If index.html exists, it's not going to ever look at index.php, so I need to give it the specific URL to the site. The PHP file that I made works, and as a side effect, we get to see a lot of info about the server that I've started running. I can fix the Apache search order problem if I go ahead and remove the original index.html file. It should then default to serving out the PHP file instead. With Apache and PHP configured, we probably want to go ahead and set up a database. Whatever application we're going to use is most likely going to be compatible with MySQL. It's free and it works really well, so that's what I've decided to go with here. I decided to add a status spinner so that this time, when I speed things up, it's just slightly less boring. Once the package download and decompress wraps up, it's going to ask you for a MySQL root password. Definitely don't forget this. Recovery is a pain in the butt. I set mine to ASDF, but you should probably pick something realistic. Administering your MySQL server could take an entire book to learn, but there's a quick check you can do just to make sure that it's up and working. There's a command line program called MySQL, and you can give it -u root for the root user and -p, which prompts you for a password. As long as it connects and you get a MySQL prompt, it means the server's up and running and we can move on to the next step. The next step, coincidentally, is installing a module for PHP 5 that lets it connect to MySQL. You have to have both in order for the two to work together. Another simple apt-get update, we don't even have to restart Apache, and we're done. This is a Linux services training video. It's not a MySQL training video. So I'm going to let you cheat a little bit. There's a very nice GUI called phpMyAdmin that you can install. It'll let you manage SQL through a web or MySQL through a web-based interface. The installation script here is fairly automatic. If you select Apache 2, it's going to set up the alias for you. It's going to configure the URL, and all you'll have to do is go to it in the website. Once you have the website up and running for phpMyAdmin, you can do basically anything that you wanted to with MySQL, create databases, all that sort of thing. Set up your credentials. I picked ASDF again. Again, create something good. And then go ahead and go back to your browser. I do highly encourage you to learn MySQL administration. Not only is it not terribly difficult, it's also a lot of fun. But again, we're concentrating on Linux here. So fire up the browser, keep your IP address in place, and put just a /phpMyAdmin. It's going to load up a new interface where you can log in using your root password that you created earlier. Take some time here to look around. MySQL, the server, can have multiple databases, and inside of each database are multiple tables. Using phpMyAdmin, you can explore into each level of this. You can create a database, you can back it up, you can run SQL commands inside of it, all without having to know the MySQL command line interface itself. With something useful finally running on Apache, we should go back and take a look at what the configuration files are now. You'll want to browse through all these configuration files on your own time. There's a whole lot of useful configuration information actually in the files themselves as comments. The first one that we want to take a look at is the apache2.conf file, which is more or less mostly comments. A lot of the configuration has been moved into other secondary files, but there's still some things that are interesting, like the lock file, the PID file, and some general configuration on how many versions or how many copies of Apache get started up, how many threads it can run. Check all of that out and read the comments thoroughly. There's another file that traditionally would be used called httpd.conf. It's actually empty now, so you're not going to use it for anything, but on older installations you may see it hanging around. One of the ones that is important is ports.conf, which determines which TCP ports Apache listens to at startup. Under normal circumstances, port 80 will be on. If you happen to turn on SSL, which is something that you'll probably want to do, it'll also start listening on 443. If for some reason you wanted to add another port like 8080 or 12345, this is the file that you would do it in. Moving on, one of the things that Apache does that's really useful is something called virtual hosting. Virtual hosting allows you to take two or more domain names and run them on the same IP address under the same Apache instance. Apache configures virtual hosts by creating a series of files in sites available, and each of the files has normal Apache syntax. Just the same as in the default file that we looked at earlier, there are certain directives that you can include into each virtual host. So there's an admin, a document root, there's custom logging information, and everything that you can put in place. So normally what you do is copy the default of virtual host, change the domain name and the document path, and you're basically done. Apache uses the domain name itself plus the combination of the IP address in order to define which virtual host that you have. If you only have one IP address, then you can set up every vhost to work on that one, and then it switches based on the name. Part of the HTTP protocol is to send the host name, which is what Apache uses to pick out which virtual host it's going to serve from. Apache actually uses the sites enabled directory to house symlinks to sites that are configured in sites available. But what we really want to do here is figure out how the Debian package installer figured out to install phpAdmin for us. So I'm checking for occurrences of literally the string phpMyAdmin in any of the files. We see here that it's been shoved into confd, phpAdmin.conf, and there's a couple configuration directives that we want to check out. The common thing to notice here is that in each of these directories in the Apache 2 configuration directory itself, there's simply files that are included in the server startup. So it's almost as if you have one configuration file that's been split into multiple ones. So when you look at this phpMyAdmin configuration file, it should look basically the same as any virtual host file. It has a directory, and at the top it had an alias. All of these directories just point to resources that Apache is going to try to pull in as if it were part of a main configuration file. If we stop for a second to check out what's in user share phpMyAdmin, we're going to see just a giant series of PHP files and not a whole lot of magic. If you're expecting some sort of executable program or anything like that, I'm afraid you'll be disappointed. All it really is a series of PHP code files that are run by Apache, starting with index.php. Hopping back into the Apache config directory again, there's one more directory that we need to cover. Mods enabled, which should be looking familiar now because of the PHP package that we installed earlier, lists all of the different modules that Apache is going to try to load at boot time. There's a ton of them, and they all do fairly specific operations. Like, for instance, on this screen you see mime.conf. This is a configuration file that tells Apache what to do with particular files. Modules in general add functionality that would be more difficult to add by modifying Apache the program in its entirety. To get a better grasp on what Apache modules are capable of doing, I want to take a look at userdir module. What userdir does is let you assign a point in each user's home directory that will be served out as if it were a normal web page. All you have to do is configure it once, and then anything that they put inside of their special directory can be served out using a sub-URL at the server. What I'm pointing out here is the only configuration that really matters for userdir, which is the directory in the user's home directory that will be served out. We're going to go ahead and enable the module using a command called a2nmod. Turns userdir on, and then we need to go ahead and restart Apache. Apache restarts will disconnect active connections, but since HTTP is stateless, for the most part this won't matter too much. But before we go further into that, a slight diversion. One of the neat features of Linux when you're sitting at the console with a keyboard and mouse is that you have virtual consoles. And the virtual consoles are simply login shells that you can access using Alt F1 through Alt F6. Each one of them gives you an independent login. What I want to do here is log in as a user so that I can create a public HTML directory and test it. But I didn't want to lose my spot in the other part of the video. So since I have two consoles, I can switch back and forth and they maintain their state. And actually, you can have up to 12 of them if you want to configure your machine that way. Most people stick with 6. Right now, I want to generate some really quick HTML so that we can test the userdir configuration inside a browser. My IP hasn't changed, so all I'm going to do is type it in again and add some stuff at the end of the URL. Specifically, there's a tilde and then the username, which is student. The tilde is what causes the userdir module to fire when Apache starts to service the page. Using this, you can pretty easily let employees or family members set up their own websites on your server. One caveat is that PHP will not work on userdir. I'll leave that up to you to learn how to turn it on. We haven't really discussed troubleshooting at all yet, but one of the key points to troubleshooting anything in Linux is to check out the log files. Fortunately, unlike some other operating system, log files in Linux are generally available and they're generally fairly straightforward to read. So, for an example, let's check out the Apache log files. Pretty much every application that you use is going to have a log file of some type, or at least service applications like MySQL, Apache, or anything like that. It's always the first place to go to whenever you have trouble. Always check the logs first. Any standard type of service log is going to be kept in var log. So first, let's take a look at var log Apache. Or actually, that's Apache 2, sorry. In var log Apache 2, you see a couple of files. The first is the access log. The access log holds everything that is kind of normal day-to-day operations. So you can see inside the log itself, you get the client IP address, the date that the access was made, what HTTP command it was, like a get or a post or whatever, the return code like a 404, a 302, or a 200, and then finally kind of some demographic information, for lack of a better term, the operating system, the type of browser they were using, and that sort of thing. This is useful for debugging to see if anybody is actually hitting the server at all. Inside the error log, you see roughly the same kind of information, but this is also where you'll see problems with PHP applications doing stack dumps or things that are crashing, reasons that Apache isn't serving out files correctly. I haven't really annoyed you too much about log files yet, so I'm going to take a moment to do that. Unlike other operating systems that I and you have probably used, and it's not the one that you're thinking of, but that one too, log files in Linux services and systems are generally pretty good. You can actually use them to get debugging information out of the software that you're trying to run. Specifically things like MySQL, Apache, bind, DHCP, any of that sort of stuff that we'll cover later also, will actually put good usable information in the log files. You should definitely check out everything in var log and get familiar with what types of information are logged in each individual file. There's a process called log rotate that every day will go through and move the old logs, compress them, and then create new blank logs, so that you generally have a running version of, say, 5 days worth of logging information. Very good to have, especially when you're trying to diagnose a crash or when you're trying to figure out why bind keeps dying for no reason. You'll get things like DNS requests served there or logged there. You'll get things like IP address assignments logged there if you're running a DHCP server. Anything in there is generally useful. You will see this and you will look in var log literally all the time. It's a great tool. Make use of it, become really familiar with it, and it's going to save you a lot of headache in the future. Moving on a little bit, I want to point out one thing that's going to get you with Apache at some point. The Apache process runs as a user called www-data, which is not a normal user you can log in with, and it's not root. It's done that way so that the permissions that Apache has when it's running are reduced. Unelevated privilege. That way, if someone finds a security bug or vulnerability or any type of problem in Apache, they attack your server. In theory, they can't get outside of anything that the www-data user doesn't have access to. This is by design, but it can be really annoying, especially when you're first starting out. So one of the problems is that you're probably going to have somebody in your group who wants to update the default website for the company or the intranet site or whatever you want to do. They're going to have to be able to write to var www as the user www-data. Otherwise, Apache is not going to be able to work with it. The second caveat that comes up frequently is that you want a web service of some type to be able to save files onto your server. It's going to have to save them as www-data, not root and not any other user. Otherwise, Apache isn't going to be able to write to it. It will come up eventually, and it's not that big of a deal, but I just wanted to point it out so that when it happens and you can't figure out why some service that you're trying to run can't save files, you don't end up banging your head against a wall for hours at a time over a simple user permission problem. When I say that Apache runs as a user, what do I mean? I mean that every process on the machine runs as some user, almost like a security context. So you have a lot of processes on the system that run as root, which means that technically they have full access to the disk, they have full access to anything that the root user can do. That's obviously a security concern. So Apache runs under its own user that's not used for anything else, and so it can't jump out of its own security context. And the www-data user is what you use for Apache on Debian Ubuntu systems. Thus, whenever you work with Apache, you have to keep in mind that it's running with a really restricted user. It's not going to have permissions to get to a lot of the files that you might want it to automatically. There's a command that we can run that tells us everything that we need to know about what processes are running as what users. It's called ps, and by default it only lists processes from you. But my favorite version of the invocation for ps is ps-aux, and it shows you all of this following information. The first column is who owns the process. The second column is the unique process ID. Then you have some CPU and memory statistics here, some more memory statistics, what TTY it's running on, if any, when it was started, what kernel process level it's in, whether it's sleeping or active, how long it's been running in CPU time, and finally the name of the executable at the end. So we can see from this display that Apache is running as www-data, which is how you would normally use it. This is another of those commands that you're going to use all the time. Pretty often when I log into a server that I don't routinely work with, one of the first things that I run is a ps-aux just to get a feel for all of the processes that are running. Specifically the two columns here, the first that's all 0.0s on this, and the second, which was all 0.2 or 0.3, show you some pretty valuable information about processes that are running on the system. When your machine's running slow or just odd, one of the first things to do is run a PS for all the processes on the system and figure out which ones are chewing up the CPU and RAM. A lot of times that's going to be your problem process. As with everything, you can do a lot with PS, but an easy way to remember this particular version that, again, I happen to like a lot, is that it's PS for all users with extended information. So I think we'll go ahead and wrap this part up. We've accomplished a lot over the last 25 minutes or so. You've got a basic web server installation that can serve out pages. You can serve out PHP pages. You have a MySQL server. Hopefully someone, including yourself, wants to delve really deep into how MySQL works. You can also run user web pages out of their own home directories without you having to deal with publishing stuff to the service. All you have to do is create a user account for them. They can upload it into their own public HTML directory. And all of this was pretty straightforward. Hopefully it was also a little easy and kind of fun. Keep exploring, play around with PHP, maybe write a simple application, and definitely play around with MySQL. Next up is going to be two network services, DNS and DHCP, that we probably will find useful in your local LAN.